In this question, we're asked about a dilution. It says a chemist must prepare 675 milliliters of a 86.0 micromolar aqueous silver 2 oxide working solution. He'll do this by pouring out some 124 micromolar aqueous silver 2 oxide stock solution into a graduated cylinder and then diluting it with distilled water. And what it asks us to do is figure out how much of this 124 micromolar solution the chemist should pour into the graduated cylinder before they dilute it to the 675 milliliters. So in a dilution question, you can use the dilution equation. C1V1 equals C2V2. It's really important to realize, because you'll use this equation a lot in the lab, that you can only use the dilution equation if you're doing a dilution. If a chemical reaction is happening, this does work by chance sometimes, but it's important not to use this during a chemical reaction, only for a dilution. A concentration times a volume gives you an amount. So the amount of solute must remain constant in the solution in order for this equation to work. Said another way, a dilution must occur. If you think about a beaker of salt water, if you have a beaker of salt water and you add more water, the amount of solute, is constant. What changes is the volume of the solution and therefore the concentration of the solution. This equation does not work if you're doing a chemical reaction. Anyway, enough about that. Let's go ahead and fill this out. So first, we need to find the initial concentration. Well, the initial concentration here is the 124 micromolar. The units don't really matter here as long as they're the same on both sides. If the units of concentration and the units of volume are the same on both sides, the intermediate units, although they may be a little strange, you do not need to pay attention to them. Next, we need to find the volume of this solution that we need to use. Well, it turns out that's the variable. That's the thing we're trying to find out and solve in this question. What concentration do we want to make from this 124 micromolar solution? That is C2. And what we're trying to make is 86.0 micromolar solution. And how much of that 86 micromolar solution do we want? We want 675 milliliters of that solution. To do the math, multiply these two together and divide by the number next to the variable, and what you'll find is V1 equals 468.14516 milliliters. Because these are all three significant figures, we want our answer to be three significant figures. So V1, so the correct number of significant figures, is 468 milliliters.